Hi everyone. What we're going to do in this clip is take a look at how we work with formulas, or we transpose formulas, for lack of a better phrase. I'm actually going to step through the example that I used in your online notes, just because it's a really good example. So what we did in your online notes is we said, well, if you're converting from Celsius to Fahrenheit, then Fahrenheit is equal to 9 over 5 multiplied by whatever the value is in Celsius plus 32. Well, that's fine if you happen to know what the Celsius is. But let's say you're in the States and you don't understand Fahrenheit too well because you've grown up with Celsius system. So they give you a value in Fahrenheit, and you need to convert it to Celsius. Well, how am I going to do that? Well, we do that by using all the different rules that we've learned up to this point. Okay, so the first thing we're going to do is we're going to take 32 off of both sides of this equation. Now, why do we do that, you ask? Well, the reason we do that is this gets this part away from this side, because that'll cancel out with our identity property. So now what I can do is I can multiply both sides by the inverse of this number. So that means I'm going to have Fahrenheit minus 32. I just rearranged that. Over, this supposed to be 9 times 9 over 5 Celsius. These numbers are the inverse of each other, and by our identity property, or our inverse property, I'm sorry, in real numbers, they will cancel out and give me a 1. So at this point, I've now sort of finished. So Celsius is going to equal 5 over 9 Fahrenheit minus 32. So again, see what I've done here. I've actually taken my time with this, and I've just done a little step at a time. But by doing that little step each time, it's allowed me to get what I'm looking for. So let's take a look at another example. And that's going to be converting miles to kilometers. So if I go 1 mile, that means I've gone 1.6 kilometers. So what if I want to find out how many kilometers it takes to go 3 miles instead, or how many miles is in 3 kilometers? Well, my formula doesn't really work that well that way. This one's a much easier example. So now what I have is, well, I'm going to take both sides and multiply them by 1 over, oops. So it's going to be k times 1 over 1.6 equals 1.6 m times 1 over 1.6. These are going to cancel out from my identity property, and I want to end up left with miles equals kilometers divided by 1.6. So that'll tell me how many miles, if I go so many kilometers. So if I went 10 kilometers, that will give me my value for miles that way. So this is just an example of how we can kind of move things around. Another quick example that we can take a look at here is power equals current times resistance, and current is I. So this is a physics thing for calculating the power on stuff. So if power is equal to current, which is I, times resistance, which is R, well, if I know what my power is and I know what my current is, how do I find out my resistance? Well, what I do here is I'll multiply both sides by 1 over R. So it'll be 1 over R, 1 over I, sorry. So I'm looking for my resistance. So 1 over I on both sides. Why does this work? Because of my equation here. As long as I do the same thing to both sides, everybody's happy. So R is going to equal P over I. If instead of looking for R, I was looking for I would do the same thing, except I would do it so if I'm looking for I this time, what I'm going to do is I want to multiply 1 over R times P equals I R times 1 over R. That will cancel my R's out on this side. P over R equals I. So all formulas do this, and they do this because of the rules that we've already talked about over the last couple of videos, and because of that equal sign. Remember, whatever you do on one side of the equal sign, you do on the other, and you shouldn't have any troubles. Anyway, I'll talk to y'all later.